Good morning, students. Today we'll look at Bash. If you recall from yesterday's class, Bash is one of the scripting language which will eventually learn to talk to the kernel and hardware. They have compiled Bash in the form of what we call shell. Okay, shell is like a layer on top of your kernel and for user. So it's like a between kernel and the user. So the Git notes which I've shared has some details in terms of what kernel is, what are the system user space, how applications will work, and eventually how and where the shell will reside. Okay. So we'll dig into what shell and how we'll eventually use shell in this session. Okay. So if you're a Linux user, you have shell by default, but if you don't have, you can open your terminal and just type sudo apt install bash. That will have your bash installed on your machine. So that will bring your bash shell. If you're on Mac machine, your terminal by default will have a ZSH shell. Okay. In this course, we'll rely on Bash because it's like an ANSI standard. People who have created new shells have used Bash as their base shell. There are many shells in market. You have C shell, Corn shell, you have ZSH shell, you have Mongo shell, you have variety of shells which will help you to talk to the underlying kernel. Depending upon the variant of kernel, your shell will change. But in the end, a shell will have certain basic ANSI properties which are by defaulted so that you can extrapolate and create your own shell for your respective kernel. Okay. If you're a Windows user, you will not have shell by default. You will have what we call PowerShell. Okay. So I'm a Windows user. So if I go to my um, search, I'll see Windows PowerShell, which is one of the variant of Bash. Okay. But if you want to use Bash in Windows, you have to have Windows subsystem enabled. Okay. So to do that, you have to go to so you will have WSL setting. This is Windows 11. Turn on Windows feature on off. Okay. So if you're a Windows user, go to search and just type turn off this feature. You will get this in the control panel.
Sir, are you sharing
This.
your screen?
Oh, I'm not. One second. Oh, I'm sorry. I thought I was sharing this. Oh, sorry. Are you all able to see my screen?
Yes, sir.
Oh, okay, great. Good. Yeah. Please unmute yourself and let me know if something is not happening. So this documentation, I'll repeat again, this documentation has required details and you will figure out where the shell will reside. And if you're a Linux user, you can just do sudo apt install bash. By default, you will have it. But if you don't have it, you can use sudo apt install bash. This is a way to install an application in a terminal, okay, in a Unix terminal. If you're on Mac, you have ZSH by default. It's another type of shell. But in this course, we'll use Bash. So you go to Homebrew and install Bash there. You'll have a many Bash apps. You can pick any one of them. If you're on Windows, you have a PowerShell. Like you go to this and type PowerShell. You have a PowerShell. This is a variant of Bash, which you can see in your Windows by default. But we need Bash to understand the standard shell so that we live with Bash. To have Bash installed on Windows, you have to go to your search and type turn Windows features on off. There's an option in control panel and that brings you this pop-up. Okay. If you scroll down till the end, you will find what we call Windows subsystem for Linux. Okay. You have to have this flag enabled. By default, it will be not be enabled. You have to enable that flag. Once you enable that flag, you can install a Unix subsystem within operating system. Okay. Within Windows system. So once this is enabled, you go to Microsoft Store, search for Ubuntu, and that will bring you various Ubuntus. You can pick any one of them. Debian is one OS, Ubuntu is one. You can do Fedora, you can do Arc, you can do Penguin. Yeah, there are many, but better go with Ubuntu 22.4. It's pretty simple. It doesn't have any issues, and the vendor is everyone. Okay, you can just install it. When you install it, you will get a terminal like this. Okay, so in your Windows, you will have Ubuntu. The app will be installed like this, and when you open, you'll get a terminal like this. Okay, if you look at this terminal, you will have what we call a command line. Okay, I hope all of you have Linux on your machine in some form in your undergrad. Maybe will be like a refresher, but you know, when you look at this course, Bash will play a key role in trying to understand the overall concepts. Okay, that's why we are doing this. So if you're already aware of these things, you can just keep quiet and listen, go with the flow. Anyway, you have notes in the grid book. For people who have no understanding on what each of these details are, I'll be very specific so that you'll understand. Okay. So if you look at this terminal, you will have a command line. Command line has two entries. One is the username. This is my username at the rate machine. Okay. Username is something which you configure when you first set up your Ubuntu. You will have it will ask for username and password. Then a username at the rate machine name will be visible in your terminal. Now this PPHLAP is my machine name in Windows. How do you see my machine name? I'll go to view my PC name, and this is my device name. Okay, but in case of Linux, I will have username at the rate machine name in the command line. Okay, this is how they present the terminal. Okay, now how do we use a terminal? You can first start with basic commands. So basic commands are like hello class. This is like a print statement. If you are aware of C, the print statement is C is printf. If you're aware of C++, it is C out. If you're aware of Java, it is system.out.len, etc. So similarly, in case of Bash, you have a print statement like echo. Okay, that will echo on your terminal. There are system variables like dollar shell. So this dollar shell is nothing but a environment variable. In Windows, you will have environment variables. For example, if you go to search and type environment variables, you will find bunch of variables which are global variables for your operating system. Like how you have a local variable and global variable in your program, the operating system being a software, it will hold certain values at a global level so that everybody can use. Now, dollar capital letters is a convention for the environmental variables in Linux. So to print the environment variables, all you need to do is do small case echo dollar home. Sorry, home. So if you carefully observe, all commands are case sensitive. So all commands should be in smaller case, environmental variable in capital case. To print the value of a variable, you have to use dollar. Okay. So home is the variable which holds home directory. This is my home directory. What is my home directory in Windows? I'll go to my home and click on this PC. This is my home directory. Okay, in Windows. Similarly, in case of Bash or Linux, my home directory is home. To print the value or path of it, I have to do $home. Okay. So what is the path of this PC? This PC is residing in C drive. So similarly, my eco home will be residing in home username. This is my folder where all my following folders will be present. Okay. Then there are many environmental variables. If you do env, you will get all environment variables. So for example, shell. Shell is a variable which will tell which shell you are currently on. So if you're in Windows PowerShell, if you do echo dollar shell, you'll get PowerShell path. If you're in Mac, if you're using ZHS shell, if you do echo dollar shell, you'll get ZSH path. Because I'm using bash, I will get bash path for the shell variable. Okay. There are other environment variables like name, which is my machine name, current working directory or present working directory, which is the folder in which all my upcoming scripts will reside. What is my login username? What is my home directory? What is the path of my Netscope for certification to see whether the machine is connected to network or not? What is the language type? And the colors you see on screen, green, blue, white, there are different types of colors which the underlying bash will utilize, etc. Okay, there are many other inbuilt environment variables. These environment variables will help you run the shell, read your instructions, and convey them to kernel, and eventually kernel will perform those tasks and return you the output. Okay, that's the intent of the environment variables. Any questions so far? This chat. Okay, there are no questions. Okay. So if you look at, I think we covered environment variables. There is a function called date, which is an inbuilt date. If you want to know the value of date, you can't do like this because it's not an environment variable or it is an inbuilt variable where it holds the value inbuilt. So it can't print the value of it. It will hold the value in the date itself. So instead doing an echo, you can just do date. It will give you the date. If you want to print date in UTC, you can do date hyphen U. That will give you the date in your UTC. Otherwise, it will read your system date timestamp, your time zone, and tries to print the date in that respective time zone by default. Okay. Otherwise, based on the arguments, you will eventually know what will be the output of a specific command. Because shell has too many commands, very difficult to memorize all of them. So there is a repository which is available. I think in last class I shared a slide. Sorry. So if you look at this HTTPS ss64.com slash bash, this will give you a very high level holistic view of all the bash commands which are available for you to use. Okay, we'll go through few of them. We'll go to some scripting logic as well so that you will understand. You don't need to memorize all of them. As you use them, you'll get habituated to those commands. Okay, so let's look at um, something called a man page. Okay, man page is like a help page which will help you understand what are the variants of the command, what are the arguments that command has, so that you can reuse them. For example, let's do man date. So this will return you a help document of a date command. So it says date will print out the system date. There are multiple arguments for it. If you do hyphen D, it will display the time in string. If you do hyphen hyphen debug, it will help you parse the date. If you do hyphen have, it will for every line it will read from the date file. So there are various other arguments which will help you visualize what all possible items you can do with the particular date function. So that's the significance of a man page. Okay. If you do jobs, just type jobs, you will see what are the processes which are running in the backend. Okay. Because I have opened man date page and didn't close it properly, I just did Control Z. I exited from that page. but I didn't stop that page. So that thread is running in the backend. So if you do jobs, and if you do jobs, you will see the underlying job which is running in the backend. If you want to stop it, okay, all you can do is type kill and give the ID value of the job, which is 1. So if I do kill 1, it's not operated because I'm not able to perform administration tasks on my machine. This is a machine where I use for at my workplace. There are certain operations that might be permitted, but if you do kill job ID, it will eventually kill the jobs on your typical machine. Okay. Now let's look at some other examples. There's a command called ls that will give you the list of files which are there in the system. There's an argument for ls which is called ls minus l, which is nothing but a file listing with additional properties. Carefully look at the output of the first and the second command. First command will give you the file listing. Second command will give you the file listing with additional arguments of who are the owners, what are the rights, size of the file, when the file was created, and what is the file name. So in the first command, you have seen everything with space delimiters, but in the second command, you see some RWX, some random usernames, some numbers, and date timestamp and file name. So this is nothing but the permission set for a given file. So if you carefully observe, this hyphen will determine whether the args.sh is a file or a directory. Directory in the sense of folder. Because all these are files, you have hyphen here. If it is a folder, okay, how do you create a folder? Mkdir folder folder 1. Okay. Now if you do ls minus l, you will see folder 1 in blue color. That will signifies the folders. And you will see D in place of hyphen. So this is how you will distinguish a folder and a file. Now if you look at the next item, which is RWX R-R-X, the first set, the second set, and the third set signifies the permissions. Okay. R means read, W means write, X is execute. By default, if you create a file, you will not have a execution rights. You will have a rights to write a file or read a file. You can't execute the file. So if you look at this permission set, the first set is a permission for the owner of the file. So if I created the file, that's the owner of that's the permissions I own. The next set is the control group. So imagine you have in Windows, if you're sharing your machine with your family members. Hey, can you guys be on mute if you are outside or yeah, thank you. So the first permission set is for you who is the owner. The second permission set is for the control group. Control group is a combination of people who share the access to the machine. Those are different user accounts. For example, in your machine, if you want to share your machine with your family members and create each login to them, and you create a group among them and name it as family, then you know that's the permission you can assign to bunch of people from that group through control group rights. So the first is the permissions of you, who is the owner. Second is the permission set of the control group. Third is for everyone else. Everybody else is similar to what you have guest account in Windows. So if you want to create a Word document and give it to everybody else, then you know you can do that in typical Windows. Similarly, in Linux, in Bash, you can see how the permissions are typically spanned between you, control group, and the everyone else. Okay. Then you have the owner of the file, the control group owner, size of the file in KBs, when the file was created, what's the name of the file. Okay, so this is what you see in the typical ls minus l, which is the file listing. Let's look at other commands like um, which command, echo. Which command will help you tell where the all other commands are residing in the machine? So these are the system files of echo or system files of any command. For example, if you want to know where is ls residing, so it is residing in bin folder. Okay. So which will give you the path of the respective shell command. Okay. Let's look at the how to write a shell script. There is an editor called Nano, like the way you have Notepad++, IntelliJ IDE, or by the way you have other IDs like Vim, um, Turbo C for C, Borderland C for C++, you have PyChamp or Python. Similarly, to write bash scripts, you can use either Vim editor or use Nano editor. Okay, to use that editor, you have to type Nano file name. Let's call it as hello world hw.sh. So .sh are the bash script files which you can execute. Okay, so to open the editor, you have to type nano file name .sh. So when you do this, this will take you to the nano editor, GNU Nano 6.2. Now to write the first bash program, you need to understand that there is a interpreter reader called hash exclamation slash bin bash. What we see over here is called shebang. It is the it's like a header file to the .sh file to tell the underlying operating system that whatever is residing in this sh file is the bash script. Okay, what do you do to what do you import to write a shell, write a C file? Can anybody tell me? You can respond in chat. What header do you import to write a C script? Stdio.h, yeah. So stdio.h, you write it primarily because you are telling the underlying Turbo C compiler to keep my standard input output devices activated. What are your standard input output devices? Your keyboard, your monitor. So when you're executing a C file, you're telling a C compiler, please ensure that all the controllers for your standard input to be active while the C code is being run. Okay. What do you do for C++? You can include in chat. What do you do for C++? What's the header you import? Correct. So IOStream. Why do we don't use std.ioh but use IOStream in C++? Is primarily because in C++ library, stdio.h is defaulted. But the C++ expects the communication between multiple C++ files to be communicated through a stream. Stream is typically the input-output connections which enable the data push among them. So that's why you do iostream.h, which is a new header file which has stdio.h inside it. Okay. What do you do for Java? Do you know? Correct. You import java.io, that is to tell your Java just-in-time compiler that there is a Java IO file which you need to load to do semantic and syntactic checking. Similarly, for Bash, you have something called shebang, hash exclamation bin bash. Okay, this is the first line which you need to use. So when I want to print, I'll clear the screen and I'll do hello world. Welcome to DevOps class. Enclosed in double quotations, the print statement is converted to yellow. Then to save it, I'll click on Control X. If you carefully observe, when I do Control X, it is asking me to save the modified buffer. It means the editor is telling me, do you want this .sh file to be stored in your hard disk? I mean in the ROM, because when I'm writing the script is currently residing in my RAM, my temporary memory. When I ask it to save it, it is telling me, can I go ahead and push it to the can I save this modify button into the ROM? Okay. Now when I type Y, the file is now in the ROM. I need to click on enter to exit. Okay. So typically, if you recall from the diagram here, you have this RAM and ROM which are directly interacting with the operating system. When shell is being executed, the kernel is loading the shell temporarily in RAM and performing the task. When you wanted to store the data or any artifact into the permanent storage, the shell will eventually prompt whether you want to push it into permanent storage or not. Then that's what you have seen in the execution terminal. Okay. So now that we have created the .sh file, as I said, if you do ls minus l, hw.sh is in white color, args.sh is in green color. But if you look at the permission set between both of them, X is not available, but you have X for argsh. So the point is, when you create a .sh file, by default, you will not have execution rights. So to provide an execution rights, you have to use a command called change mode, okay, which is nothing but chomd. To add execution rights, you have to do +X, okay, on hw.sh folder. So chmod is changing the mod of the file. What are you doing? You are doing +X. When you do +X, it will add X to you, control group, and to everyone. So it will touch all the three sets. Okay. And when you hit enter, oh sorry, this is change mod. I'm sorry. When you press enter now and do ls minus l, you now see that the X is available for hw.sh. Previously it was in white color. It didn't add any X for execution. Now you have it. Okay. It means that this file is now ready for execution. So to write a file, you need to use nano editor. To add a permission, you have to do change mod. To execute it, you have to use what we call dot sourcing. Okay, dot sourcing. Dot sourcing is dot backslash hw.sh. Okay, this is called dot sourcing. You will have to execute a shell file using a dot sourcing approach. When you do dot backslash hw.sh and hit enter, it will execute the logic from the sh file. You will have hello world, welcome to DevOps class, which is part of the HW file, right? If you go to nano hw.sh, you will see the echo with the clear screen. So that is why you have the clear screen. hw.sh, it clears the screen and tries to sprint. Okay. Now if you do jobs, yeah, you still have it. Okay. So this is how you write a shell script. This is our first Hello World program. Any questions so far? Okay. What you can do after this class is follow this document, look out all the basic commands and try them out by yourself. Okay. I'll explain some concepts and I'll eventually run some scripts in next 30 minutes so that you will understand what are the other concepts you eventually have. Okay. You can also try it from your end while I practice. Okay. Now let's look at another small script to print the values. So let's do nano print.sh. I have a script which says clear the screen. When you do just echo, it will blank the page. Continue. So this is a comment line. Okay. When you have hash continue, this is a comment line. This is before. Okay. So there's a command called read hyphen n for hyphen p. Read is the command to read the text from the UI. In C, it is scanf. In C++, it is cin. In Java, it is system.in. Okay. Similarly, in case of bash, it is read. Okay. Now, hyphen n signifies number of characters I need to read from the UI. So I need to read first four characters. If I give number 4, it means first four characters. Hyphen p. Hyphen p is from where I need to read. I need to read from the prompt, from the UI. Okay. And assign it to a value called project code. Okay. So this is a print statement and this is the variable. This is how you declare a variable. Now, how do you print a variable? Dollar. You print a variable using dollar. Okay. So you have a read command hyphen n, which is an argument to read number of variables. This is the count of variable, and this is from the prompt. This is the variable name, and this is how you print the value inside the variable. Okay. Now I'll save it. It will be asking me to move to ROM. I did it. Execute. Now I have to give the permissions because .sh will not have execution rights by default. Now I'll execute this file using .sourcing, and when I click on enter, screen gets cleared and I will be asked to provide the input. So I'll give you the input dev ops. So when I type 4 characters, as soon as I end the 4th character, my control will be gone because in my code, the code which I am using expects me to read only 4 characters from the prompt. Okay. Because I read only 4 characters, when I try to type the 5th character, I will be kicked away from the UI and the next line of execution will happen. Okay. So this is our typical input, like a scan of example. You can see from the screen. Okay. Let's look at the arguments. Let's look at the arguments. So as I said, it is case sensitive. If you type capital letters, it will throw an error because the kernel will not understand. You have to write a commands in small letters. Let's look at arguments.sh. Okay. Now, if you carefully observe, there is if and else, which we have as an example. If test, you have a basic shebang link here, then echo to print the screen, empty screen. If test $1 equal to blank, will tell what is $1. Okay. Then echo there is no $1 supply. Then test $2 and echo, then exit. If you look at the if syntax, it starts with if judgment condition, then print statement and exit. Exit will kick off the if else. Okay. How do you close an if? You reverse the if. This is the closure. So this is the first if logic. This is the second if logic. What is it judging? It is judging the values coming from $1 and $2. Okay. We'll see what are $1 and $2. Okay. Let me exit. I already have permissions for arch.sh, so I'll not give special permissions. I'll just execute it by .sourcing. Okay. So right now, what you see on the terminal is my username @machine name and the terminal indicator, and whatever you see right after it is nothing but $0, which is the first argument to my terminal. The second argument which you pass to this is $1. Let's assume I am passing 21. This is the way I pass an argument. And I have a second argument called 3. Okay, this is $2. So I'll repeat. This is $1. What you see on screen is $1. This is, sorry, $0. This is $1 and this is $2. Okay. So when I execute this script, it says 21 plus 3 is equal to $1 and $2. Compare the script example here. Okay. I hope the screen is visible, right? Can you please say yes or no?
Yes, sir. Yes, sir.
Okay. So if you carefully look at the script, whatever I'm passing as part of ARGS 21 and 3, they'll go and sit here. $1 is nothing but the first argument where 21 will go and sit here. If it is blank, it will tell no value was supplied. $2 is nothing but 3, the second argument from the command line. If it is blank, then it says no value supplied. In the end, irrespective of the if logic, I am writing an echo statement outside the if logic, which is nothing but $1 plus $2. This is how you use the arguments in a script. But if you observe, we are using $1 in single quotation. When you use dollar values, argument values in single quotation, you will literally print $1 value. You will not print the value inside the $1. Okay. Let me show you an example. Look at the output. We passed 21 and 3. 21 is going here. It's not blank, so the if logic will not run. 3 is being passed here. If logic will not run because it's not blank. Then you have 21 here and 3 here. That is what you see in this output. But because we placed $1 in single quotations, you are actually printing the $1, $2 value. So the idea is, if you have to compare logically the arguments, you place them in double quotations. If you want to just print the value, use without quotations. If you want to print $1 as a string, you have to use them in single quotations. Okay. This example will help you understand. Now let's not pass the second argument and just pass 21. It says no second value supplied because 21 sat here, it is not blank, so this if logic didn't execute. 3 was not passed, so this test condition has passed, so this echo statement was printed, no second value submitted, and it got exited. So there is no point in executing this last statement. Okay, so that is why the script eventually exited at the second if. Now let's pass no arguments. Okay, when you do no arguments and print enter, there was no value passed, so $1 is blank, and the echo statement returned no first value supplied. Okay, so this is how you can have arguments passed and verified whenever you write a bash script. Okay, so this is one example on the arguments. So similarly, you have $0, $hash. $0 is the first file name of the script. $hash is to know how many arguments are we passing to the script. $, etc. You can try them out and verify from your notes. There are other input-output redirection, I guess, which you might have already have some familiarity in your undergrad, but you can just see that if you are using a greater than or less than symbol, it means that the output of first command will become an input to the second command. Okay, so that's how the input-output redirection will happen. This is a kill job. We already looked at it. We looked at built-in variables. Let's look at this manipulating variables. Okay. Nano rm stats.sh. So we are reading a city name as part of the query, as part of the script. And in the echo, we are trying to print the machine name and naming a file called hostname.stats. We are basically doing bidirectional. It means that whatever name is being printed will go sit in this file. Okay. Then we are reading city name. We are printing the city name, which we are reading from line 1 because we are actually reading from the prompt. Then if you carefully observe, there is a command called uname-a in tick symbol. This tick symbol is in the right left corner of your keyboard. Okay. So if you look at your typical keyboard, in your right left corner, you will have something called a tick. This one, this piece, that is the tick. This is tick. Okay. This is what you see in the script here. You have to enclose a command in ticks when you execute it in echo. Okay. So look at kernel info. We are executing machine name -a, which will give you the name of the kernel, and that is being executed in the tick within ticks, and that will go sit in the same file. And there's another environment variable called $version, which will give the version of your bash, and there is a file. And in the echo statement, you're actually writing everything into the file. Okay. Now you do Control X, save it into ROM, change the mod, execute, give the city as Trichy, and the file got created. Now try to open the file. pph-lap -01678 underscore stats.txt. So if you open, you will see these values here in the file. So basically we are reading and writing into the file. What is the machine name? This is my machine name. The next item is kernel info. My kernel info is Microsoft Standard WSDL WSL2. And what is my shell version? Shell version is 5.1.16-release. So we are basically reading the values and pushing them into a file remotely through a script. Okay. So this is how you can write a stats of your machine. Similarly, you have a number of user logins, etc. And these are all print statements. Yeah, let's look at math functions. Okay. In case of Bash, Bash have 3 types of math functions. One is what we call standard let function. Okay. Next, the one is expr expression. Then you have double parenthesis, and then you have what we call BC, which is your basic calculator. Okay. Let's look at let. So for example, you have let a equal to 10 plus 10. Echo $a will give you the value 20. Okay. This is how let will work. It supports all arithmetic operations. You can see all the variations in the documentation. Okay. Similarly, you have expr. Okay. Let's look at expr 51 plus 10. If you observe let and expr, let is required to be equated to a variable, and you have to print the value of the variable. expr doesn't have that challenge. You can pass the computation statement direct to expr so that it will return the output. Okay, that's the primary difference. expr also supports all possible arithmetic and logical operation like addition, subtraction, multiplication, division, modulus, etc. There's another aspect for calculating a mathematical expressions, that is double parenthesis. Okay, if you do this and type equal $a, sorry, there should be no space. Carefully observe the let, expr and double parenthesis. Okay, let is actually equating the math equation to a variable. Expr is executing the equation on demand, but double parenthesis doesn't use any external command. It is equated to a variable, but it is actually storing the math equation of value inside A. So it is doing the dollar of this equation and storing the value in A. So when you do echo A, you get 47. Okay. So for example, if you do echo 25 plus 34, it will throw an error because it may not be able to understand what exactly you are trying to do, because you are not equating it to any value. But if you want to print this, it gives you a value because you are doing the dollar of this value, which is nothing but printing the value of the variable. The command line assumes the double parenthesis is one of the form of an inbuilt variable, performs the computation within the double parenthesis, and helps you return the math output. So these are three variants which you already have in the shell. There is one more way to calculate it, that's called basic calculator. Okay, it is not available by default, you have to install it. So to install it, what you do, apt get install, so sorry, sudo apt get -install bc. Yeah, it's bc. Oh sorry, sudo -get install bc. Okay, so it's asking for my password. I'll give my password. Oh, apt get. Sudo apt-get install bc. If this installation is done. Okay, now let's use the example we have from the class. Let's call it as nanocal.sh. If you observe this, we are reading number of hours worked, hourly wages, and we are doing a computation on demand. So if you look at this, we are equating gross pay. We are multiplying both hours worked and hourly wages and passing a pipe delimiter. This is input output redirection. Okay. The output of this command will become an input to this command. So this is basically executed under double ticks. Okay. So if you want to execute combination of commands, you ensure that they are placed in double ticks. And you are basically printing the gross pay from this equation. Okay. Now let's save it into the disk, add the permission, do the dot sourcing, and execute. Something went wrong. Okay, it's primarily because it's not able to identify these quotations. Hours worked 45, hourly wage 5 rupees. Okay, so it has some other. Okay, there need to be a space. Command not found. Okay, because of spaces, it couldn't return. So I've removed the spaces. So if you observe, it is actually trying to do the comparison. It's actually trying to do the calculation using BC. So look at the script versus the output. It is reading hours worked, which is 45. It is reading hourly wages, which is 5. And it is doing the multiplication using BC function, and it is actually printing the output. Okay. So there are minor errors. This double quotations, I think they are not converted into this shell. You remove and ensure that it has a yellow color change. And then there's a space over here. Remove the space. Okay. Then you will eventually able to execute it. Okay. So similarly, you have other keywords like test to do the testing equality, which we already have done, which supports and condition or condition, etc. Ensure that you try out the basic commands today, sometime. In the next class, what we'll do, we'll look at some basic loops for 15 minutes, like for loop. There are 5 variants of for loop, some while loop, do while loop, and case statement. And there are also some good examples which I've collated here for your assistance. You can also try them out and read them and understand how to write a simple bash scripts. Okay. You will have your first assignment on your bash, where we'll typically do all file management using bash. I'll try to announce the assignment maybe on Thursday. I will give 2 weeks. Typically, I'll announce the schedule. I'm looking at pushing the assignment through the Git classroom. So please create your GitHub ID accounts by accessing github.com and share those IDs with Ashish, okay? So that I can add you all in the GitHub classroom and publish the assignment so that eventually within the due date you can submit the assignment, okay? Any questions so far? What is test indicating in ARGS file? Okay, good. So if you look at ARGS file, ARGS uses test to do judgment. Test is a command to verify any condition which has equality or logical condition. So for example, if you want to check if a variable has a string, if a variable is equal to 25, if a variable is not null, all those judgment conditions can be evaluated using test keyword. Okay. If you use this test and if, it will facilitate if to do the judgment. Okay. Because if and else are nothing but conditional statements, right? You don't use parentheses like how you use in conventional C, but in case of bash, you use test to evaluate the judgment condition. Some examples of test are available in the basic commands. If you scroll down till the end, you will have options on how to test single statement using greater than less than symbol and doing multi statements. Like for example, if you recall your concepts from statements and sets from your undergrad, you have a truth table, you have contradiction table, right? True, 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 false, 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 true. The similar logic will be applied to the test command. So you can do test between statement A and statement B. You can have test between statement A and B or C. So that type of judgments can be done using test command. Okay. Any other questions before we close the session? Okay. So in next class, we will learn some functions and loops. Okay. And we will learn Git and version control. I'll try to publish the notes mostly by Friday for both of these sessions. Okay. So that you'll be ready. On Thursday, I'll announce the assignment mostly on 30th, and you will get time until 13th of Feb. Okay. To finish your assignment and submit to Git. Okay. Wonderful. If you have any questions while you practice, if you are stuck anywhere, please feel free to write to me to my email ID. I'll try to answer them as soon as possible so that you are not stuck. Okay? Great. Are we good to close the call, Ashish?
Yes, sir. Thank you, sir.
Okay. Thanks, everybody. Have a great day. Please practice. It will help you to do the other upcoming activities better if you do the hands-on on Bash. Okay. Thank you and have a great day. Bye.